And what else you got here? It looks like you got some other core samples.
Right. These are actually specimens that we fabricated in the laboratory. And what we can do is we can simulate loading on these materials, and we're going to demonstrate that in a moment. Just show you the machine that makes these grooves in the pavement. But what we can do is we can simulate the effect of traffic on the pavement on material that we bring back to the lab and fabricate into specimens. And so we can actually see how good it's going to hold up under the loading of traffic.
And these are all different types of gradation of stone and different types of materials?
Yeah, these are all different materials, and as you can see, they perform differently. Obviously what we're looking for is the least amount of deformation in the actual specimens themselves. Those are going to perform much better with traffic on them than the ones that really deform.
In other words, where there's more marks in the pavement.
Right, you'll see a much bigger groove cut into them from the wheels going back and forth across them.
And are all these using rocks? I mean, I understand there was one of them that you said might contain using old broken up roof shingles. Is that true?
Yeah, there is one of the mix right in front of me right here does contain 5% roofing shingles in it that from tear-offs that were ground up and mixed into the pavement at the time that the material was being produced at the mix plant. And so here it is. It's actually from a roadway in Manchester.
Wow. So I mean, what you're really doing here is experimenting with other kinds of materials to recycle things. Not only use the rocks that you have to get out of the ground brand new, but basically taking things that have already been used once and finding new ways to use them, and maybe possibly even pavements.
Right. One of the things that we can also do is whenever you see a road that's got all the groove marks in it where it's been milled off,
yes,
we're able to recycle all of that material back into pavement. Asphalt is one of the only materials that's 100% recyclable. And also in this particular mix that had the shingles in it, we also have 15% recycled asphalt product in here, so pavement material. So we're actually able to do a fair amount of recycling, and we actually have one experiment going on right now on 395 where they're using up to 40% recycled materials on the roadway itself.
Well, very good. Well, why don't we take a walk over to where you make these cylinders and test them?
Okay.
Thank you.
So when we bring in the mix from out in the field loose, we can bring it into the lab and we can actually fabricate specimens and be able to test that material so that we can see how well it's going to compact out in the field and whether or not it's going to have the properties we're looking for so that it will have a long, durable life. And so in this right here, we're just taking some material and we're going to compact it in the gyratory compactor, and all we're going to do is dump the material into the mold itself, and at that point we will put it in the machine and it will compact it, and we will then be ready to roll. And what this machine actually does is it actually kneads the material together so that it's not just hammering it down, it's actually massaging the material so that the particles can lock together much better than if you just sit there and essentially try to pound them in together. So this really simulates what's going on out in the field when you see the large rollers out there actually compacting the pavement as it's going down. And here you can see the machine itself is just going around and around. There's a ram that came down inside the mold to apply downward pressure, which you can't really see. But then what you end up with is this material is being kneaded together so that it locks together as tightly like it would under a compactor out in the field. And so while this is going around, all it's doing is just slowly compacting that material and squeezing the air voids out of it. Then we'll just take a jack and actually push the specimen out of the mold, and then we allow it to cool off, and then we can do other testing on it, such as the rut tester or many other tests that we run. And so we'll allow that to cool for a minute, take the paper off, and then we will have a test specimen there ready to go. What this machine here does is this actually simulates the effect of traffic going over the roadway. We can actually compact specimens here in the lab, and we can load them in into this chamber, which is temperature controlled. Normally we would run this test with the doors closed so we can control the temperature, but we have it open just so you can see what's going on. We have rubber hoses in there, and the steel wheels go back and forth on the rubber hoses across the asphalt sample itself, so that we can actually measure how much the material actually shoves ruts out of the way, similar to what would happen in the wheel paths as you've seen on different roadways, where the asphalt itself will actually form little gullies in the wheel paths themselves. The better the mix is to resist that, the smaller the indentations we'll make on these specimens themselves. Hit it, John. And so this will go back and forth about 8,000 times, and it measures the depth after every cycle back and forth. And so at the end of about 2.5 hours, it's done 8,000 cycles on it. And so what we're looking for is a material that doesn't really form very large ruts in the actual pavement itself. So you end up with a fairly minimal amount of change in the shape of the material itself. So that's how we can do that, and that's how we generated those specimens I showed you before.